Welcome. My name is Franziska and I will give you an overview of our IMC 2020 paper, which is called The Lockdown Effect, Implications of the COVID-19 Pandemic on Internet Traffic. Here you see a list of all of the authors of this paper, without whom this paper would not have been possible. COVID-19 and the Internet. Why are we looking at this context? To give you, maybe you're a viewer from the future, to give you a little bit of a context. Right now we are in October 2020 and the COVID-19 pandemic has wreaked havoc across the world for the last couple of months. Everything started around beginning of 2020 when the pandemic was unleashed across the world and we started to go into lockdown. We stopped going outside. We had very close social circles, and in general, social life at some point came to a stop. And if you look at the newspaper articles that we show you here, there's a lot of connection between COVID-19 and the internet, because as you see here, we're forced to stay at home. All our possible social connections were done via the internet. And not only social connections were moved to the internet, also our work was done remotely from home, facilitated by internet connectivity. Same goes for remote teaching. Pupils are also not allowed to go to school because the groups are too large and it would be too risky in times of a pandemic. And even family life in these times went virtual. And the question arose, the internet is essential in all of these efforts, but how well does it actually cope? The goals of this presentation are basically threefold. We want you to understand from our perspective as measurement scientists how the COVID-19 pandemic affected our vantage points. We present you results from a diverse set of vantage points across the internet graph as well as across the globe. And we will show how actual changes in human behavior are directly reflected in internet traffic and the resulting statistics. Let's have a look at our various vantage points. We start off with 3 internet exchange points, one in Central Europe, one in Southern Europe, and one on the US East Coast. As you probably all know by now, internet exchange points interconnect networks. So they have a mixed bag of customers across the entire internet economy. Here you see a list basically of features, how our IXPs look like. They have a large number of members, huge amounts of peak traffic, and we rely on IPFix that is directly collected at the public peering platforms. Of course, as this data is highly confidential, it is kept strictly on-premise and analyzed there, and all results are aggregated. Our second vantage point is a Central European Internet Service Provider, and as Internet Service Provider, we focus here on residential customers who are working from home. It's an ISP that services about 15 million fixed-line subscribers and operates a Tier 1 transit network. It doesn't host CDN caches on its network, but it has a very diverse peering infrastructure. In this paper, we basically focus on 2 parts of the data set that the ISP provided us. We look at net flow that we captured at the border network gateways if we want to have a focus on the subscriber view of the customers of the IXP. If we want to look at the traffic from an AS level perspective, we look at net flow that has been directly collected at the border routers. All data, again, is analyzed strictly on-premise and all results are aggregated due to its confidentiality nature. Our third vantage point is an educational network in the Madrid region. It interconnects a lot of university and research centers, and as such, it services scientists, students, mainly on campus. The network interconnects 16 universities and research centers and serves about 290,000 users. Again, we are provided with anonymized net flow data that was captured on the border routers. In order to understand the relationship between the pandemic and the internet and the behavior that we can actually measure on the internet, we need to look at a lot of data. And to kind of condense our result and make them comparable, we base our analysis on 4 weeks that represent the course of the entire pandemic from February 2020 to June 2020. We basically choose 4 weeks. The first one is the base week. That is a week in February, well before the lockdown. We choose a week in March, right after the lockdown was in place. A week in April, when we observed the first relaxations of the restrictions, and a week in June, where we have the minimum restriction level and social and business life was almost back to normal. Here you will have an overview of the weeks that we chose, but for the remainder of this talk, the numbers are not important. Just recall that we have the base week, March, April, and June that we will compare in the rest of this presentation. Now let's have a first look to get an idea how actually the COVID-19 pandemic impacted traffic on a high level. What I show you here is a time series that covers January 2019 until June 2020. We show you 2019 to give you an idea how the traffic at our vantage points would normally behave. So what you see here is the increase of 2019 as it was measured. And you can already see for the ISP that once the COVID-19 outbreak in Europe started, and especially with the lockdown, we see a huge increase in traffic. So the increase that you see started at the gray shaded area is what an ISP normally experiences over multiple weeks, even months. That we saw here in only 1 week. Similar story goes for the IXPs. Here we see basically the same behavior. And for 2 of the IXPs, for the Central European and for the East Coast IXP, this behavior actually persists. A different trend is shown in data from a mobile operator in Europe. Intuitively, it makes a lot of sense because once the lockdown started, mobile traffic decreased. That means we were all at home, we were not traveling, not for pleasure, not for business, not to meet friends. We spent most of times in our homes, so mobility decreased and so did mobile traffic. Okay, let's have a more detailed look on how the traffic volume actually changed. Here you see a time series and I will show you data for our 4 reference weeks that we analyzed at the ISP and have a look how the traffic looked before, during and after the lockdown. Here in blue you see our base week, you see the usual diurnal patterns, and if you look now at March, a week directly after the lockdown, you see vast peaks and valleys that slightly filled. And if you look at what I'm indicating here, we see a 30% increase in peak traffic at Saturday afternoon or evening more. If we now go to April, the trend is still there, but it's declining a little bit, and same goes for June. The valleys still are a little bit more filled than what we saw in February, but that may even be attributed to the general growth that we expect over the year. Another pattern that we were very interested in as we are looking at the impact of human behavior on traffic patterns is how the workday and weekend relationship changed over time. What I show you here is a time series in 24-hour bins for 1 day, namely Wednesday, February 19, before the pandemic. And on the y-axis, you see the normalized traffic volume. So you see a pattern that we are kind of expecting. During the night, the traffic levels reduce. And during the day, they are on the medium level. And to the evening hours, they increase. Because what does it depict? At night, most people sleep. Then they go to work. Then they come home and start their usual evening choirs and maybe watch video streaming or do voice chat with their family or whatever else we do on the internet. If you compare that to a Saturday, here, February 22nd, before the lockdown, the pattern is different because the elevated traffic levels start way more early because we don't leave for the office. And many days we are still at home and follow our usual social activities at home. And these patterns are actually important for network operators to understand because they really like to be able to predict how their traffic behaves on which times of day. And now, if you look at the pandemic time, especially the lockdown time, here in purple you see a Wednesday, so a work day on March 25th after the lockdown. And if you compare the purple and the blue bars versus the purple and the orange bars, you see that the Wednesday looks rather more like a Saturday. But that rationale makes a lot of sense because we're at home and we work there, we live there, we educate our children there, so we behave even more like a regular weekend. In order to shed a little bit more light of this pattern, we did a bit of a differential analysis. Based on the time patterns that I showed you before, we classified days into work days or weekdays based on the traffic patterns they inhibited. Here you see a time series from January to June 2020, and again with normalized traffic volumes. At the upper part of the plot, you see Saturdays and Sundays that are classified as weekend patterns in blue, and Mondays to Fridays that, based on their traffic behaviors, that are classified as weekend-like in orange. On the lower part on the plot, it's the other way around. In blue, you see Mondays to Fridays that are classified as workday, and Saturday and Sundays you see in orange if they're classified as workday too. So basically, if you see something that is orange, it is classified differently from what we expect it to be. Namely, a Sunday is classified as a workday and a Monday is classified as a weekday. It will all come together now. So, if you look at that, we basically see that before the lockdown, everything looked like we expected. Everything is kind of blue. Saturdays and Sundays behave like weekends and Mondays to Fridays like weekends. But once the pandemic starts, things changed. Again, we are forced to stay at home, so we inhibit behavior that we normally would only do on a weekend. And this behavior at the ISP more or less persists even in the time when some of the people are going back to the offices. And to compare that with the IXP, there the pattern is even more pronounced. So we can summarize at both vantage points, workdays during the pandemic are mostly classified as weekends, which changes the way we are actually looking at network graphs. Okay. In order to shed light on how people are actually using their traffic, so doing a little bit more of a qualitative analysis than only telling you when they were relying on their connectivity, we did a classification of our entire dataset based on transport port information and AS level information. We normalized our traffic statistic to the minimum and maximum of the 3 previous weeks, and as the early morning hours showed no real changes, so people are basically still sleeping at night, we removed them in order to improve the readability of our plots. What you see here are heat maps of our 2 base weeks for 2 vantage points, namely the ISP and the Central European IXP. We ended up with 8 categories, namely web conferencing, collaborative working, email, video on demand, gaming, social media, educational traffic, and CDNs. Note that traffic from the class educational does not actually refer to traffic that is involved in remote teaching, but that is traffic that is related to ASs that are involved in educational networks. So what do we see here? Here you see for each day of the week in February that we looked at a heat map on how busy this traffic class was over time. So, for example, I highlight here email, and you see it is mainly used during working hours, so in the first portion of the day. If we look at CDN, video on demand, gaming, and social media, the usage increases rather in the evening hours. And we hardly see any web conferencing. So apparently in Central Europe, we didn't do web conferencing before the pandemic. Let's have a look at our actual results. What I show you here is a heat map, basically the same one as before, but rather than showing you the relative traffic levels of the respective classes on the respective day, it shows the difference to the base week. So we compare the results of March to the traffic levels in February and show you the increase or decrease. So what do we see? We see a large increase in web conferencing, collaborative working and educational traffic. But we also, which is a bit counterintuitive, see a decrease in video on demand and gaming. The explanation for gaming is quite straightforward. We had unusually high traffic levels in the class of gaming in February. So if we compare that to our week in March, we end up at a decrease. For video on demand, the things are a little bit more interesting, but here we can only speculate. You see that until mid of March, we see an actual decrease in video on demand, and then we see a decrease. As many of you probably recall, the major streaming providers, due to the pandemic and the impact it may have had on the internet, reduced their video resolution for at least 30 days. We may capture this reduced resolution in our dataset, but we cannot really be sure. Let's have a look at April. Here we see similar effects, but the growth in email is less pronounced and we see a slight decrease in social media traffic. In June, the picture looks again similar, but web conferencing, for example, focuses more on the working hours. So people restrict their work times a little bit more, or many people are actually back to the office, and we may see the impact of that here. We still have a moderate growth in collaborative working. Educational is still on the rise, probably due to the video conferencing service that is offered by one of the big educational networks we see here, and we again see the decrease in video on demand, gaming and social media. For the IXP, the picture basically looks similar. In March, we see again increase in web conferencing, video on demand and also in gaming. We see a partial decrease in CDN and educational traffic, and strong increases in web conferencing in April and June, and decrease in CDN and social media traffic. So basically everything that is related to people staying at home sees an increase. In addition to that, in the paper you can find an in-depth analysis comparing hypergiant traffic to traffic inhibited from all the other ASs. And I can tease here a little bit at the results. As you saw, that basically web conferencing, email, and educational traffic were on the rise in our classification. This is not necessarily only served by hypergiants or even mainly by hypergiants. So this is a reminder, if you want to do an analysis on this kind of traffic, it's not sufficient to only focus on the hypergiant traffic. Next, I show you a case study that we conducted at the Southern European IXP, focusing explicitly on gaming traffic. I show you here a time series with the normalized unique IPs we counted at the IXP. Again, the results are pretty expected, given that that region also had a strong lockdown. We see a large increase in number of active IP addresses, and our data also shows a strong increase in data volume that is exactly correlated with the start of the lockdown. Another topic that we specifically focused on is VPN traffic. Why did we focus at VPN? Because VPN is what facilitates companies to connect usually their road warriors and in pandemic times their personnel that is working from home. We did the study at the Central European IXP. So how did we identify VPN traffic? Basically, our identification is twofold. One side is port-based, so we take all the well-known port and protocol combinations that are exclusively used by VPN services. The other classification that we used is DNS-based, so everything that is TCP 443 and the IPs in the DNS are labeled with VPN, but not www, we classify as VPN traffic. Here I show you again over the course of the pandemic how VPN traffic in these two classifications behaves over time. This is the baseline for February, and if you compare it to the numbers in March, you see a 200% increase in domain-based VPN traffic during working hours. We see a slight decrease in April and similar behavior in June. But we can conclude, as more people are working from home, either companies did a fallback on their already existing VPN infrastructure, or even some may have rolled out new VPN infrastructure, but we definitely see an increase in VPN-related traffic. In the last part, we focus on our third vantage point, the educational network. Note that we have a much broader and in-depth analysis of this network in the paper. Here we will focus only on a highlight result due to time constraints. In this plot, I show you for 3 weeks of our observation periods the ratio between ingress and egress traffic at the academic network. In blue, you see the base week again, which is a week in February. In green, you see a week in March, which is a transition period between on-premise lecturing and online lecturing. And in purple, you see a week in April, which is completely online lecturing. What do we observe here? We see that during the base week, we have strong differences between the traffic ratios between workdays and weekends. During workdays and working hours, we have a traffic ratio, ingress and egress, from 15:1. So when people are on premise and utilizing the network, they consume much more traffic than they send. On the other hand, if you look in the transition period, this ratio is already reduced. There we have a ratio from 6:1, and once we go back to the online lecturing level, so most people are actually leaving campus, nobody is working there, nobody is attending lectures, we have a ratio that is as low as 4:1. So here we actually see a contraindicative trend compared to the ISP and IXP. Here the traffic levels are actually reduced because people leave the place where they usually use this network. So let's recap what we found. Our key observation is that changes in people's behavior directly manifest itself in changes in traffic patterns. So once we were all under the lockdown and stayed at home, that directly led to the emergence of new traffic patterns. In accordance with that, the difference between workday and weekday vanishes, and applications for remote working, education, VPN, and video conferencing saw a significant increase. On the other hand, the absence of users, as we saw in the educational network, can lead to a decrease in traffic for certain applications, networks, or even areas. Many of the relevant applications that served our work and education life are not actually served by hypergiants. So we showed you that a sole focus on hypergiant traffic is not sufficient. We have an in-depth analysis of that in the paper. So all in all, we find that the impact of the COVID-19 pandemic is directly reflected in changes to internet traffic patterns that we can actually measure. If you recall the news media coverage in March 2020, many people were actually openly raising the concern whether the network can actually withstand our new demands. With the lockdown upon us, we were all focused on the internet as sole means of interacting with friends, family, and doing our work. So many people were scared that we would face traffic increases about 100 or 200%. But actually what we found is increase of traffic levels about 15 to 30%, but within a small amount of days right after the lockdown. And if you keep in mind that networks usually provision for about 30% of increase over an entire year, that was a very drastic increase in a very short time, and networks needed to react quickly. On the other hand, impact on peak traffic was limited, and the valleys, so the minimum traffic levels, got a little bit more busy. To understand how network operators actually reacted to that change, our paper includes a small study about capacity increases at the Central European IXP, which increases its capacity about 1,500 gigabits per second. Overall, networks can actually accommodate for such sudden changes in demand if they are planned with enough spare capacity and quick reaction times. And with that, I conclude my presentation. Thank you.